DevOps and CI-CD Part 21. This episode has 3 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is Notary? Here's a strong way to approach it. What is Notary? Notary is an open-source project that enables container image signing and verification. It allows publishers to digitally sign container images and allows users to verify that those images come from a trusted source and have not been tampered with. Notary is the technology behind Docker Content Trust. DCT. Why Notary? Without image signing. Docker pull ginks. Latest you don't know who published the image, whether it was modified, whether the registry was compromised with Notary. Docker pull ginks. Latest verify signature trusted image only signed and trusted images are pulled. How Notary works. Notary uses 1. Public or private key cryptography. 2. Digital signatures. 3. Trusted metadata workflow. Developer sign image registry. Notary server client verify signature. Docker Content Trust. DCT enable DCT. Export Docker Content Trust equals 1 push signed image. Docker push repo or payment service. 1.0 Docker automatically signs the image, stores signature metadata in Notary, pushes image to registry, pull image. Docker pull repo or payment service. 1.0 Docker verifies the signature before pulling. Key types in Notary. Root key, highest trust key, used to establish trust. Root key signs repository keys. Repository key, targets key, signs image metadata. Payment service. V1 snapshot key protects metadata versions. Timestamp key ensures metadata freshness and prevents replay attacks. Example workflow. Sign image. Docker push repo or app. V1 metadata created. Root JSON targets JSON snapshot JSON timestamp JSON verify image. Docker pull repo or app. V1 verification. Signature valid trusted publisher image untampered. Notary architecture developer sign v registry leads to Notary server cap. Client verifies components. Registry stores images. Notary stores trust metadata. Clients verify signatures. Limitations of Notary. V1. Complex key management. 2. Difficult key rotation. 3. Docker-centric design. 4. Less Kubernetes native. 5. Operational overhead. Because of these limitations, many organizations have moved towards SIG-store-based solutions. Modern alternative. Cosign. Today most Kubernetes and cloud-native platforms prefer cosign. SIG-store advantages. Keyless signing. OIDC integration. Kubernetes native easier automation. Example. Cosign sign GCRIO or project or app. V1 cosign verify GCRIO or project or app. V1 Notary versus cosign feature. Notary cosign Docker Content Trust checkmark crossmark container signing checkmark Kubernetes native limited checkmark keyless signing crossmark checkmark OIDC integration crossmark checkmark popular for modern K8s less common checkmark interview answer. 1 minute. Notary is an open source framework for digitally signing and verifying container images. It is the foundation of Docker Content Trust and uses public or private key cryptography to ensure image authenticity and integrity. When an image is pushed, Notary stores signed metadata, and when the image is pulled, the client verifies the signature before use. This prevents deployment of tampered or untrusted images. While Notary was widely used with Docker Content Trust, many modern Kubernetes environments now prefer cosign and SIG-store because they provide simpler key management, keyless signing, and better cloud-native integration. Nice. Let's continue. Question 2. Explain SBOM. Here's a strong way to approach it. What is SBOM? SBOM, Software Bill of Materials, is a complete inventory of all components, libraries, dependencies, packages, and modules used to build a software application or container image. Think of it like an ingredient list on a food package. Why SBOM is important? When a security vulnerability is announced, organizations need to quickly answer, are we using the affected library? Without an SBOM, search source code, manually check container images, inspect dependencies, hours or days of effort. With an SBOM, search SBOM, find affected component, identify impacted applications, take action immediately. Example. Suppose your application uses Payment Service Spring Boot 3.2 Log4j 2.17 Jackson 2.15 PostgreSQL driver Apache Commons. The SBOM records all these dependencies and their versions. Real-world example. Log4 shell. During the Log4 shell vulnerability disclosure vulnerability, organizations asked, do we use Log4j? Which applications? Which versions? Companies with SBOMs could identify affected systems quickly. Companies without SBOMs often spent days investigating what information does an SBOM contain. Typical fields. Field example package name log4j version 2.14.1 supplier Apache license Apache 2.0 hash SHA-256 dependencies other libraries component type library framework OS package example name log4j version 2.1.4.1 supplier Apache license Apache -2.0 inches SBOM for containers container image payment service v may first contain Ubuntu base image OpenSSL Python Flask requests NumPy application code and SBOM lists everything inside the image SBOM formats SPDX created by the Linux Foundation. Most widely adopted format. Example, SPDX version, SPDX 2.3 package name, log4j package version, 2.1.4.1 Cyclone DX created by the OWASP Foundation. Popular in DevSecOps and container security SWID software identification tag standard. Less common in cloud-native environments SBOM generation tool SIFT generate SBOM from container image. SIFT Ginks. Latest generate SPDX. SIFT Ginks. Latest OSPXJSON Trivi image. Format Cyclone Ginks creates SBOM and scans vulnerabilities Anchor Enterprise SBOM and Compliance Management SBOM in CI/CD Modern Secure Pipeline. Git commit build generate SBOM vulnerability scan sign image push registry deploy SBOM and supply chain security SBOM is a key requirement in modern software supply chain security. It helps with vulnerability management dependency tracking compliance audits license management incident response third-party risk assessment frameworks that encourage SBOM usage. SLSA OpenSSF SBOM versus Vulnerability Scan SBOM Vulnerability Scan lists components finds vulnerabilities inventory security assessment shows dependencies shows CVEs static catalog risk analysis used for visibility used for remediation and SBOM does not tell you if something is vulnerable, it tells you what exists. Vulnerability scanners use the SBOM to identify affected components interview answer. 1 minute. SBOM, or Software Bill of Materials, is a detailed inventory of all software components, libraries, dependencies, and packages used in an application or container image. It provides visibility into what software is running in an environment and is essential for software supply chain security. SBOMs help organizations quickly identify impacted applications when vulnerabilities such as Log4Shell are disclosed. Common SBOM formats include SPDX and Cyclone DX, and tools like SIFT and Trivi can generate SBOMs as part of CI/CD pipelines. SBOMs are often combined with image signing and vulnerability scanning to strengthen DevSecOps and MLOps security practices. Great. Moving on. Question 3. What is BuildKit? Here's a strong way to approach it. What is BuildKit? BuildKit is the modern build engine used by Docker to build container images faster, more securely, and more efficiently than the legacy Docker builder. It is the technology behind Docker build in modern Docker versions. Why BuildKit? The old Docker builder had limitations. Slow builds, poor caching, sequential execution, weak secret handling, large image sizes. BuildKit solves these problems by providing checkmark faster builds, checkmark parallel execution, checkmark advanced caching, checkmark secret management, checkmark multi-platform builds, checkmark better CI/CD performance. Example traditional Docker build. From Ubuntu run apt-get update run apt-get install y Python 3 run pip install Flask old builder. Step 1 Step 2 Step 3 sequential execution. BuildKit. Analyze dependencies, parallelize operations, reuse cache efficiently, build completes much faster, enable BuildKit temporary. Export Docker BuildKit equals 1 build. Docker build. Or Docker BuildKit equals 1 Docker build. Key features 1. Parallel build execution. BuildKit executes independent stages simultaneously. Example. From Node 20 as frontend build, frontend from Maven. 3.9 as backend build, backend BuildKit can process both stages in parallel. 2. Advanced caching legacy builder. Layer changed everything, rebuilt BuildKit. Reuse unchanged layers only, rebuild what's necessary faster, CI/CD pipelines. 3. Cache export or import, store cache remotely. Example. Docker BuildX build. Cache to equals type equals registry. Cache from equals type equals registry. Useful in Jenkins, GitHub Actions, GitLab CI Cloud Build. 4. Secret management bad practice. NVA secret key equals kisses secret becomes part of image history. Build kit. Run. Mount equals type equals secret. id equals os. The exact commands and code are in the written question bank. Alright, next question. That wraps up this episode. Nice work practicing, and see you in the next one.